In this example, you're being asked to predict the major product or products of each of the following reactions. If no reaction takes place, write no reaction. All right, so again, we're in lecture 14. We haven't talked about other reactions yet, so we're not really going to start looking for any side products. We kind of know that this is potentially going to be an SN2 or no reaction at all. In the future, you won't be able to just say that because you'll have a lot more reactions you have to look at and consider. All right, so we're just going to go through the process here. I like to start by looking for a good leaving group, and that helps me identify the substrate. You can look for the nucleophile if you want. First, here's a nucleophile right here. Remember, that is a species that's going to have electrons that can be donated, whether that species has just lone pair electrons or a full negative charge. It's pretty obvious this is our nucleophile here, with the nucleophilic atom being the carbon here. It's dissolved in acetone, an aprotic solvent. Great for SN2. That must mean this is our potential substrate. But the question is, do we have a good leaving group? And unfortunately, in this reaction, we do not. We have to remember that fluorine is actually a pretty bad leaving group because it is very difficult to break that carbon-fluorine bond. It is a very strong bond, and these fluorines will typically never act as a leaving group here. So what does that mean? It means we don't have a good leaving group. So it means even if we have a decent nucleophile like we do here, it can't do anything. I'm going to draw this nucleophile out as it actually is. That nucleophile cannot do anything. So even though that fluorine is causing a buildup of positive charge on that carbon, this step here, which I'll draw, but it's not happening. This cannot occur because that bond between carbon and fluorine cannot break. So remember, carbon can only have 4 things bonded to it. And if that cyanide group is going to come in there and add to that carbon, something has to leave. It's not going to be that fluorine, and it's definitely not going to be a hydrogen. So no reaction in this example because fluorine is a bad leaving group.